Recently, very important news were published about James Webb and a lot of news. The first news with us says, James Webb Space Telescope forecasts clouds of melted rock on this blisteringly hot exoplanet. The James Webb Space Telescope has performed a weather report for a distant planet. The powerful space telescope forecasts extreme wind speeds, blisteringly hot temperatures, and blankets of rock clouds for the world, named WASP-43. As such, the extrasolar planet demonstrates just how strange alien planets outside the solar system can be. WASP-43 orbits a star located around 283 light-years from Earth. It sits so close to its star, in fact, that it completes an orbit in just around 19 Earth hours. This proximity, equal to around just 2.1 million kilometers, means the planet, with a mass around 1.8 times that of Jupiter and a width 0.9 times that of the gas giant, is tidally locked to its star WASP-43. The JWST transiting exoplanet early release science team was able to use the telescope's mid-infrared instrument to classify the climate of WASP-43 and the type of weather it experiences on its day and night sides. Team member Laura Krayberg, director at the Max Planck Institute for Astronomy, said in a statement, "With the new observing power of JWST, WASP-43 has been unveiled in unprecedented detail. We see a complex, inhospitable world with furious winds, massive temperature changes, and patchy clouds likely made of rock droplets. WASP-43 is a reminder of the vast range of climates that are possible on exoplanets and the many ways in which Earth is special. WASP-43 was discovered in 2011 because of a dip in the light scientists saw exhibited by WASP-43. This dip occurred as the planet crossed between the face of its star and Earth from our perspective. During the transit, scientists also saw that infrared light the planet emits in response to starlight varied. The main result of the JWST investigation of WASP-43 was thanks to this infrared light variation observed between the day side and the night side of the exoplanet as it orbited its star. The variations more particularly helped scientists build a map that shows how temperatures are distributed across the entire hot Jupiter. Ultimately, the team found the variation in temperature between day and night sides of WASP-43 was too great to be seen in an atmosphere bereft of cloud cover. However, any possible clouds above WASP-43's surface are not likely to be water-based like those enshrouding Earth. They wouldn't even be ammonia, clouds like those we see around Jupiter. WASP-43 is just too hot for either. Rather, this world's clouds might be made of rock. Vaporized material, such as rock, is carried from the day side to the night side of WASP-43 by powerful winds reaching speeds of 9,000 kilometers per hour. That's 3.5 times as fast as the top speed of a jet fighter here on Earth. Then once on the night side of the planet, scientists believe this material cools and condenses. This means the thick cloud cover on the night side of WASP-43 is likely composed of droplets of liquid rock that had vaporized on the planet's day side. To that end, the researchers found that the day side of WASP-43 appears to be cloudless. To determine the composition of WASP-43's atmosphere, the team split the observed infrared light into separate wavelengths, thus creating what's known as O spectra. Because chemicals and elements absorb and emit light at characteristic wavelengths, they leave behind fingerprints in such spectra. Taylor Bell, team leader and a scientist with NASA's Ames Research Center, said in the statement, "With Hubble, we could clearly see that there is water vapor on the day side. Both Hubble and Spitzer suggested there might be clouds on the night side, but we needed more precise measurements from JWST to really begin mapping the temperature, cloud cover, winds, and more detailed atmospheric composition all the way around the planet." Not only did the JWST investigation determine that water vapor is found all over WASP-43 on both its hot and cooler sides, but it allowed the scientists to see a lack of methane in the planet's atmosphere. Hot Jupiters are normally expected to produce water and methane on their night sides via reactions between hydrogen and carbon monoxide. The team thinks WASP-43 lacks methane because its raging winds pass these reacting molecules through the night side of the planet too fast for the molecules to react with anything and create methane in detectable amounts. Any small amount of methane that is created would probably mix with other gases and quickly get carried to the planet's day side, where intense heat destroys it. The JWST isn't done with WASP-43 just yet. A separate team is currently using the $10 billion telescope's near-infrared spectrometer instrument to perform a follow-up study of the planet. Not only should this improve the MIRI temperature map, but these observations should also lead to measurements of gaseous carbon monoxide in the atmosphere of WASP-43, providing a better overall picture of this extreme world's chemical composition. The second news with us says, NASA prepares for intense sunstorms on Mars during a solar maximum. 2 NASA spacecraft will pay special attention to increasing levels of radiation that bombard Mars during this year's approaching solar maximum to better prepare astronauts for future missions to the Red Planet. Every 11 years or so, the Sun experiences a peak in activity known as solar maximum due to its strong and constantly shifting magnetic fields. During this period of the solar cycle, the frequency and intensity of sunspots on the solar surface increases, generating solar flares and coronal mass ejections that send powerful streams of solar radiation out into deep space. While Earth's magnetic field largely shields the planet from the effects of such solar storms, Mars is not afforded the same protections because the Red Planet lost its global magnetic field long ago. As a result, Mars, along with any resident spacecraft for future crewed mission to the planet, is more vulnerable to intense solar activity. That's why NASA's Mars Atmosphere and Volatile Evolution Orbiter and Curiosity rover will team up to study solar particles and radiation streaming toward Mars from both high above the planet and at its surface. Shannon Curry, principal investigator for MAVEN, said in the statement, "For humans and assets on the Martian surface, we don't have a solid handle on what the effect is from radiation during solar activity. I'd actually love to see the big one at Mars this year, a large event that we can study to understand solar radiation better before astronauts go to Mars." Together, both spacecraft study the quantity of solar particles that reach Mars and how energetic they are. Curiosity's radiation assessment detector instrument measures how the planet's thin atmosphere affects the intensity of the particles that reach the Martian surface, as well as how radiation breaks down carbon-based molecules on the surface, from which researchers can infer how much protection astronauts exploring Mars may require. You can have 1,000,000 particles with low energy or 10 particles with extremely high energy. While MAVEN's instruments are more sensitive to lower energy ones, RAD is the only instrument capable of seeing the high energy ones that make it through the atmosphere to the surface, where astronauts would be. MAVEN and Curiosity work in tandem such that the rover team is alerted to look for changes in the RAD data when the orbiter detects a solar flare. Therefore, the MAVEN mission also provides an early warning system for other Mars spacecraft teams when radiation levels are expected to rise so that they may turn off vulnerable instruments. This year's solar maximum coincides with the start of the dustiest season on Mars, which is triggered by the planet's warming atmosphere during perihelion, the point in Mars' orbit where it is closest to the Sun. Therefore, if a global dust storm were to occur at the same time as a solar storm, it could lend insight on how Mars became the freezing desert it is today. NASA officials said in the statement, "While there's little water left on Mars, mostly ice under the surface and at the poles, some still circulates as vapor in the atmosphere. Scientists wonder whether global dust storms help to eject this water vapor lofting at high above the planet, where the atmosphere gets stripped away during solar storms." One theory is that this process, repeated enough times over eons, might explain how Mars went from having lakes and rivers to virtually no water today. The last news with us says, a Switzerland-sized hole opened in Antarctica's sea ice in 2017. Now we know why. Each austral winter, Antarctica undergoes a radical change. Sea ice surrounding the continent expands outward, effectively doubling Antarctica's size. But during the winters of 2016 and 2017, a rare hole called a polynya opened in the middle of the sea ice, one about the size of Switzerland, and scientists have just now figured out how it came to be. The hole was named the Maud-Rise Polynya for the seamount, or underwater mountain located beneath it in the Weddell Sea. According to a new study, it ultimately formed due to a combination of wind, ocean currents, and underwater geography that created the perfect salt conditions to melt the sea ice. The Maud-Rise Polynya goes back further than 2016. It was first identified by Earth-sensing satellites in the 1970s, most notably during the winters from 1974 to 1976. Scientists assumed that the Polynya would return each winter, but that hasn't been the case. That has only reappeared sporadically and for brief periods. Study leader Aditya Narayanan, a postdoctoral research fellow at the University of Southampton in England, said in a statement, 2017 was the first time that we've had such a large and long-lived polynya in the Weddell Sea since the 1970s. In 2016 and 2017, the circular ocean current in the Weddell Sea was stronger than usual. As such, upwelling around Maud Rise brought warmer, saltier water closer to the surface. Study team member Fabian Roque, a physical oceanography professor at the University of Gothenburg in Sweden, said in the same statement, "This upwelling helps to explain how the sea ice might melt. But as sea ice melts, this leads to a freshening of the surface water, which should in turn put a stop to the mixing. So another process must be happening for the polynya to persist. There must be an additional input of salt from somewhere." Using data from satellites, autonomous floats, and tagged marine mammals, the team determined that turbulent eddies around Maud Rise brought more salt into the area, which was then transferred to the surface through a process called Ekman transport. Through Ekman transport, water moves at a 90-degree angle to the wind above and influences ocean currents. Study team member Sarah Jill, a professor at the University of California, San Diego, said, "The imprint of polynyas can remain in the water for multiple years after they form. They can change how water moves around and how currents carry heat towards the continent. The dense waters that form here can spread across the global ocean." Thank you very much for watching. Goodbye.